Okay, so what we have seen until now is a formation of the syntax tree for the given regular expression. Now, from this syntax tree, we have already seen the deriving of first pause and last pause of the given values for each of the expression. Now, once we have the first pause and last pause values, we basically find them to find the value of follow pause, which is much more important in the given algorithm. Now to find the follow pause, what we have is we always evaluate the value for only the concatenation nodes or the start nodes. If there is a or symbol or if there is a normal expression or normal variable present, then we do not need to find the follow pause of those values. So whenever there is a concatenation node and we have a left child and a right child in it, so what we say for each of the last poses are present in the first child, we will say that the value of the follow pause for that node will be the union of for each of the last pause of C1, we will be having will be unioning them with the first pause of C2s. And for a star node, we'll see for each last pose, there will be another first pose. Like for every last pose on the star symbol, there it will go to another first pose. We'll see that through the example here. Now we have here we have the star symbol. So what we have is we have 1 2 and 1 2. This is the last pause, this is the first pause of the star symbol. Now the algorithm says for every last pause in the star symbol, the it will be union with the first pause. So what we can say is for every last pause there is the first pause. So 1 will be going to 1 2 and 2 will also be going to 1 2. So 1 here goes to 1 2 and 2 also here goes to 1 2. And now what we do is we move on to the concatenation symbol. Now a concatenation symbol rule says that for each of the last poses in C1, it will be followed by the first poses in C2. So all the last poses in the child, which is this for the star symbol, it will be followed by the it will be followed by the right child. So the last process of C1, first process of C2. Last process of C2 is 1 comma 2. Wait a second, I will just erase it. Yeah. So what we can say is, yeah. So the for the we are talking about the concatenation symbol here. So when the concatenation symbol, we need to look at the last pose of the left child and the first pose of the right child. So for each of those, for each of the last pose in the left child, there will be first pose added. So for 1 it will go to 3, for 2 also it will go to 3. So hence for 1 and 2 values we get 1 2 3 and 1 2 3 values. Similarly, let us go to the next concatenation symbol. Now, next concatenation symbol, again we look at these values. Now 3 we have the last pause and here 4 we have the first pause. Hence 3 goes to 4. Now if we when we go to this place, we have 4 and 5, 4 and 5, and hence it is the answer here. Similarly, it will go from 5 to 6. And finally, when we have here, we don't need the follow pause for this situation. Now we will form the following tree from the earlier states what we have got. We will see that 1 can go to 1, 2 or 3, and hence 1 can go to itself, 1 can go to 3, and 1 can also go to 2. Similarly, we will make for each of the other steps as well. Yeah. So now what we will do is we have numbered each of the node as one. Like this number 1 basically represents A, 2 represents B, 3 represents again A, 4 represents B, 5 represents B, and 6 represents hash symbol. Now what we can say is now we will form the DFA from these steps. For doing this, we will get the following DFA. It is not basically minimization of DFA. From this DFA, this table will be finding the DFA finding. For this, what we have, we'll start with the first pause of this value, the topmost value, that is 1 2 3. This will be our initial state always. The top value, the first pause of the topmost concatenation will be our initial value. So 1 2 3 will be our first value. Now 1 2 3, when we get an input of A, where will it go? Now we know that A is represented as 1 and 3. So when 1 2 3 is there, what all other states can it go? 1 2 and 3 is there. With A symbol, it can, when 1 2 3 is there,